In this lesson, we're going to learn how to solve for exponents using something called logarithms. Let's begin. First, think about doing these in your head. There are 3 questions. All 3 of them have an exponent as your variable. 3 to what power equals 9? 3 to what power equals 27? And 3 to what power equals 81? I bet you can play around with the numbers, or you might even know the answers to those from your mental math. But try to figure these 3 questions out before the rest of the video plays, so pause it. Hopefully you've gotten these 3 figured out. 3 to the second power, 3 squared is equal to 9. You probably knew that one, so that was pretty simple. 3 times 3. 3 to the third power, which is 3 times 3 times 3, is equal to 27. So 3 times 3 times 3 is equal to 27. And, well, you probably figured out that 3 to the fourth power is 81 just by, thinking about what happens when you multiply 27 by 3. But if you had to use a calculator, that's fine. But now let's think about this question. What power could you raise 3 to so that you get 50? 50. Well, where is 50 between? We got a number between 27 and 81. So we would think that that number in the exponent would be somewhere between 3 and 4. So you can guess and check. You can try to figure out, what number between 3 and 4 is going to get me 50. So you could do 3 to the 3.5. And it looks like that's going to be a little bit less than 50. So maybe go to 3.6, a little bit over 50. Maybe go 5.5 or 5.6 or 5.7. And if you look at 3.56 and 3.57, you might say, well, it could be one of those two. That's pretty close. And that, of course, would be an estimate. You could also do an equation where you're doing an intersection of the graph, 3 to the x power, and you could do y equals 50. And you can move that graph. It might take a second, or you could zoom out if you want. And you get about 3.561. But again, the graph is just an estimate, raising to the third power. So ultimately, we should have a method to solve for this, and that's kind of where logarithms kind of play that role. So what happens is a logarithm, you may never have seen a log before, but a logarithm, if you have a graphing calculator or even a scientific calculator, your phone's calculator, if you turn it sideways, probably has a logarithm. But they don't do very well with these type of equations. So I'd advise using Desmos or your graphing calculator for logs. So with a logarithm, we can actually get exactly what the answer is without having to resort to intersections or estimating. So 3 to what power equals 50? Well, you could do, if you press the math, there is a log button here, but let's not use that right now. If you press the math button on this calculator, if you have one, and you hit log base. Every log has a base, just like an exponent has a base. The base of 3 to the x power is 3. So that's the base. So anything you put in the log, that's going to be that number raised down, that's going to be the number in it. Then it's going to ask you to put something in here. Well, that's going to be what it equals to. That's the value it equals. So the base in there, and then the value in the parentheses. So again, look at my calculator. Log, you'll type base, and you'll put 50. And like I said, it was about 3.56, right? So that confirms it. In 0.8, you can go as far out as you want to. Mr. Weiser, I don't have a TI-84 calculator. No worries. Desmos has you covered. What you'll do is you'll type the letters LOG. LOG. Then you'll hit the underscore. And if you don't know what underscore is, shift minus. Again, LOG. Do this with me. Shift minus. Hit the 3, and then hit the right arrow. Now you can hit parentheses and type 50, and you can get your answer. Alternatively, if you're on Desmos, you can hit this show keypad down there, click on functions, click on miscellaneous, and there's an option to do log. So functions, miscellaneous, log A, and down there in that place where the A is, you could put the 3, right arrow, and you could put 50. So you have a couple ways to do it on Desmos, but this is your answer, 3.5608. So no guessing and checking, no graph intersections. That's what a logarithm does. It solves for exponents. So just to recap, to solve the following equation in Desmos, you're going to do the following. Again, I'm going to model it with you one more time. I'll clear this out. You're going to type log, so LOG. You're going to hold down shift, and you're going to hit the underscore, so the minus sign, so shift minus. You're going to type in the 3, you're going to right arrow, and you're going to do parentheses 50. That's going to get you 3.56. So if you want to check it, 3 raised to the 3.5608779501. You get the idea. When you go out all those decimal places there, you're going to get your answer, 50. Now, we can round these to 2, 3 places. That's fine. But understand that the more you round, the less accurate it's going to be in the end. So 3.56 is as much rounding as I would do on this. I wouldn't say 3.5 or 3.6 or 3 or 4. 3.56, at least 2 decimal places. So that is the process. Logarithms are, they solve for exponents, but it has to be in the form base to the exponent equals some amount. So again, it has to be base to the exponent equals some amount. So it has to be in this form. So real quickly, just a little color coding here. The base here in the exponent, that's the same number that's down in the subscript in the log. What it equals to in your exponential form, that's the number in the parentheses in the log. That goes in the amount spot. And then the exponent, that gets its own special spot in the log after the equation. So it just kind of flip-flops, you know, and I want you to take note of that here. Base to the exponent is the amount, is the same as log of whatever base of the amount, and then that's equal to the exponent. In the next couple of videos are examples that you can explore.